Okay, so Module 10 is the data analysis lecture. Now that we've gone through different ways of setting goals, defining problems, and coming up with interventions, looking at different models of single system design, now that we've actually got our data, comes to the point where we can analyze it and make some discussion about whether or not we've met the level of statistical significance, describing our data, and different types of significance. So as I discussed in the previous section, there's the 4 different properties of graph data, and also there's different measures of trend. So when a problem is operationally defined and is either increasing or decreasing over time, neither the mean or the median are really going to be good, accurate summaries of that data. So from this data, we can see a negative increasing trend because the plus and the negative sign are flipped here. So central tendency isn't really going to give us the information that we want. It isn't going to be a really good way to describe the data that we've got here. Similarly, if we've got a positive decreasing trend, because again, the positive and the negative are flipped here, again, central tendency isn't really going to give us the information that we need. So here's where we would want to measure of trend. So one way to do that is acceleration line technique. And that gives us an idea of what would expect to happen or what would expect to continue if the data kept going the way that it was. And in a way, it's an average of the different data points along the line. So from this graph, we can see the intervention phase would expect to continue with a negative decreasing trend here. So with time, you would expect that with what we see that eventually we would be going down to 0 and probably staying there. So maybe an example of this could be smoking cessation, where at the very first data point, 24 cigarettes per day, and then towards week 5 or month 5, then they're down to like 2 or 3 a day, and we would expect that over time they would be completely abstinent of smoking cigarettes. Or obviously the flip of that. If we were to think of this as something we wanted to increase, maybe minutes spent studying per day, we would also see a positive increasing trend here, which we would expect to continue on if the intervention were to stay in place. Acceleration lines can really be used to describe patterns in data with more precision than visual analysis alone, because it tells us whether or not the trends are moving at an accelerated rate or potentially decelerated rate. So sometimes if we're looking at 2 trends that kind of maybe match one another, so if the baseline is going up and also the intervention is going up, sometimes the intervention is going up but at a faster rate than it would have during the baseline phase if an intervention wouldn't have been in place. So maybe without the intervention, the problem would have improved by itself, but by using acceleration lines, we can see if there's an accelerated rate of improvement or a decelerated rate. And again, acceleration line connects the midpoint of the first and the second halves of the phase. And in doing that, it kind of helps us get a better idea of what the trend is or what the slope of the change in behavior is. Also worth noting, when outliers are present in either half of the phase, calculating the acceleration line using medians. There is a way to do this statistically, and it should also be pointed out if you don't have too many data points that you should probably not use acceleration line because they can be really susceptible to outliers. So the more data points you have, the more accurate your acceleration line graphs are really going to be. So here's a good example. Number of cigarettes smoked per day. We can see that from the green line is the intervention phase, and the blue line is obviously the baseline, the blue triangles. So from the information that we got from the blue triangles, it looks like there is a negative decreasing trend in cigarettes smoked per day. But with the intervention phase, we can see that that's actually accelerated rate of reduction. So you could say that although a client's daily number of cigarettes would be expected to decrease over time, based on the acceleration line from the baseline, the intervention phase is associated with an accelerated rate of reduction in daily cigarettes smoked. Likewise, from this data, you can see that John's baseline spending for amount of money spent gambling would be expected to accelerate if there was no intervention put in place. So without an intervention, it seems like you'd probably be spending more and more every week. But the intervention phase is associated with a decreasing trend in money spent per week on gambling. You can also use this with your verifying source, your collateral report. So the collateral report might suggest that although the baseline spending was expected to decrease over time, the intervention phase was associated with an accelerated rate of reduction in spending as opposed to the baseline spending average. So with the 3 standard deviation band approach, This is another way to detect statistical change from one phase to the next. But this is for specific points as opposed to an average baseline score to an average intervention score. So again, kind of going back to this normal curve, doing a 3 standard deviation band approach basically turns this normal curve onto its side. And so if there's any point that falls outside the 3 standard deviation band approach during the intervention phase, then there's been a statistically significant change in that intervention data point from the baseline mean. So here's an example. Looking at this information, we can see the upper control limit and the lower in green and the lower control limit in light blue. And if we put the normal curve transposed onto our data point, we can see from this example that there are no data points that fall outside of the 3 standard deviation band approach. So none of these data points are a statistically significant change from the baseline mean. So this isn't too commonly used. I wouldn't recommend it for your first SSD unless maybe you had a really significant reason to for maybe some kind of outliers in your data. So if your data do not exhibit a trend and if they are not autocorrelated, then you can use this approach to see if there's specific data points that lie outside of what would be expected within the normal probability range. What's a little bit more common and probably what you are going to be using for your paper is a t-test. So a t-test determines whether there's been a statistically significant difference between the baseline and the intervention phase. But the first step here is to test for autocorrelation. So when we talked about the assumptions of statistics in the previous modules, we first have to meet the assumption of independence of observation and that our data is not autocorrelated. And it's recommended that you have at least 6 data points if you're going to be doing a t-test. So 6 data points per phase, so 12 altogether. Otherwise, having too few data points, your t-test may be a little bit misleading. So types of significance, there's statistical significance, which is based on a t-test. If you have a statistically significant t-test finding from baseline to intervention, that's great. And then you would follow that up with a measure of effect size, which would be a d-index. But if you don't meet statistical significance, sometimes clients can talk about practical significance, which is basically if the improvement is significant from the client's perspective, which seems kind of intuitive because that's what we would want with our intervention. Even without any kind of statistical significance, if they meet their goals that they've set out to, then that should be acknowledged and something that you should celebrate as a clinician.